In a world where single unknown chemical compounds exist, it is up to the students of Linfield Chem 322 to determine the identities of 3 unknown chemical compounds. The objectives to properly identify the identity of chemical compound number 2 were met by using physical properties such as boiling range, solubility, and odor to identify the functional groups within the compound. Functional group tests are used to further characterize the product. Finally, a solid derivative test can be performed to confirm the suspected identity of the unknown compound. These techniques can be used to try and determine any single unknown compound. Before any chemical tests are performed on the unknown compound, initial observations are made. As you can see, the compound is a clear, colorless liquid. It has an off-putting scent of roadkill and ammonia. It looks like there are a couple milliliters in the test tube. The boiling range of the unknown was taken, and it was between 104.7 to 107.2 degrees Celsius. Upon heating, there was no apparent color change or degradation of the compound. A solubility test was performed and the compound was first mixed with water. There were some Schlieren lines and then it formed a single layer. The test tube became warm to the touch. This indicates that there was a chemical reaction that took place and the compound is soluble in water. The pH of the mixture was about 11 or 12. If we look at the solubility flow chart, solubility in water and a pH above around 8 suggests that the compound is a low molecular weight amine, as seen in the green box on the left. The smell of rotting flesh and ammonia is consistent with these results. After a functional group is suspected, a functional group test can be performed on the unknown compound to further characterize the chemical. The test that was performed on the suspected amine was the Hinsberg test. This test is used to discriminate between primary, secondary, and tertiary amines. Figure 1 is an example mechanism of how these tests work. The amine reacts with benzene sulfonyl chloride and the sulfur and nitrogen atoms become bonded. This molecule becomes a salt with the potassium ion, which is aqueous in basic solutions. When the hydrochloric acid is added to the solution, the amine functional group becomes protonated and insoluble in the basic solution, causing a precipitate to be formed. The reaction shown in figure 2 for the secondary amines is almost the same, but the product of the amine and the benzene sulfonyl chloride is a neutral molecule, so it is insoluble in solution. In this case, it does not need the acid to protonate the molecule to form a solid in aqueous solutions, like the primary amines did. Controls were performed so that we could compare the results to that of the unknown. In this test, the different known amines are mixed with benzene sulfonyl chloride, then reacted with a base, in this case potassium hydroxide. Because each amine, primary, secondary, and tertiary, has a different qualitative result, these can be used to compare to our experimental amine. The results of these tests are shown in Table 1. The primary control was clear and yellowish, then when acid was added, a precipitate was formed. The solution was light pink. The secondary control was yellowish as well, and after being vortexed, a peach-colored waxy ball of precipitate was formed. There was no signs of reaction for the tertiary amine, even after acid was added to solution. The unknown amine was vortexed for about 15 minutes, when finally a waxy globular precipitate was formed. This suggests that the unknown compound is a secondary amine. The final step is to perform a solid derivative analysis. This is to confirm the final identity of the unknown compound. Because benzylphenamide derivatives are used, we can use a solid formed in the Hinsberg test. Initially, I chose dipropylamine, which was one of the 2 potential secondary amines based on the solid derivatives chart. This was a guess based on the boiling point of the pure compound, which, looking back, the benzylphenamide derivative does not have an appropriate melting point. Anyways, the test was performed and the following melting ranges were given, shown in Table 2. Because the 50-50 mixture does not have a close melting range, this means that there are contaminants and the unknown compound is not dipropylamine. This leaves one potential compound, piperidine. The benzylphenamide derivative was made and the results are shown in Table 3. Looking at the melting range of the 50-50 mixture, it is quite narrow and consistent with the melting range of each derivative. This confirms the identity of the unknown as piperidine. If we consider the authentic boiling range of 104 to 106 degrees Celsius from the Sigma Alders safety data sheet, it is quite comparable to the experimental boiling range of 104.7 to 107.2 degrees Celsius. Other initial observations of the compound are consistent with the descriptions on the safety data sheet, such as clear, colorless liquid. Information on the odor was not available. The IR spectrum of the authentic piperidine from the spectral database of organic compounds can also be used to confirm the functional groups and the identity of the experimental compound. The peak at around 3300 is a nitrogen-hydrogen stretch, which confirms the presence of a secondary amine, which is consistent with the results from the Hinsberg test. The second notable strong peak is a carbon-hydrogen bonds from the heterocyclic part of the molecule, shown on the bottom right under the spectrum. The objectives of the experiment were met by distinguishing the identity of an unknown molecule using the following techniques: initial observations and solubility tests to suspect a specific functional group, further characterization of the molecule using appropriate functional group tests, and choosing an appropriate solid derivative compound to confirm the identity of the molecule. Because the compound was soluble in water with a high pH above 8 and odors consistent with the description of amines, it was most likely that this was a functional group present. After performing the Hinsberg functional group test on the experimental compound, it was evident that a secondary amine was present. Using the solid derivative document provided, the appropriate derivative was narrowed down to two options. The boiling point of the derivative was considered when selecting a compound, and the unknown was successfully determined as piperidine. Figure 4 shows a diagram of this molecule. According to PubMed, piperidine is a widely used secondary amine that is oftentimes the building block of pharmaceuticals. It gets its name from the Latin genus name piper, which is the word for pepper. This was named accordingly from the ammoniacal scent which can come off as peppery. Throughout the analysis of the single unknown compound, the objectives of this experiment were met.
Music.